Hello everyone. In this video we're going to be introducing another method that helps us deal with non-right angle triangles. Let's go over the questions from last class first. I'll just take a quick scroll through these because you hopefully know your way around sine law well enough by now. So here's question 1a, 1b, here's 2, and 3. Interesting fact, this tree is actually taller than the tallest known living tree in the world. And here's question 4 and number 5. So we know how to use sine law, but there are some situations where sine law doesn't work for non-right angle triangles. In those cases, cosine law is often helpful. If we want to determine a missing side, we use this form of cosine law, which reduces to Pythagoras' theorem in the limit that a goes to 90 degrees. And if we want to determine a missing angle, we use this form of cosine law. So we can produce this formula from this equation if we do a little bit of algebra. So the ways of labeling the triangle is the same. The angles are marked in capital letters. The sides are opposite in lowercase letters. And here's where cosine law works. If we know an angle and two neighboring sides, we can determine the opposite side. And if we know all three sides, we can determine any one of the angles we want to inside the triangle. So let's look at an example. In this example, we need to find side length r. Unfortunately, none of the variables in this triangle match up with the formula that we were just given. So this isn't a huge problem. We can either adapt our formula or relabel the triangle. I'm just going to relabel the triangle this time. So we'll call that A and A. We'll call this B and B, and we'll call this C and C. And now we can just plug in what we know into this formula. So we go 4.3 squared plus 6.5 squared minus 2 times 4.3 times 6.5 times cos of 61. So that gives us 18.49 plus 42.25 minus 27.100 and some other digits. And now it's a quick step to figure out what a squared is. It's 33.639. We square root both sides, and we find that a is 5.8 kilometers. In this next example, we need to figure out what side length y is. This time we're going to adapt the formula. So we're trying to figure out what y is, and we use the other two in place of b and c. So x and z will go in for b and c. And then we need to take the cosine of angle y. So now we plug in what we know. This side length is z, this side length is y, this side length is x. So we get x squared, which is 12.1 squared, plus z squared, 12.3 squared, minus 2 times 12.1 times 12.3 times cos of 41. So that gives us 146.41 plus 151.29 minus 224.646, and we get 73.05. That's y squared, and we just need to square root both sides of this, giving us y is 8.55 centimeters. In this next question, we need to figure out this side length, which would be called side length C. This is side length A, and this is side length B. So we could relabel this triangle and call this length A so that it fits in with this formula, but we're just going to adapt this formula instead because we need to know C. These two will be the other ones, so these will be B and A in our case. So our formula will become C squared equals B squared plus A squared. This order doesn't matter, by the way, because addition is commutative. 2 plus 3 is the same as 3 plus 2. And then we subtract 2BA times cos of C. And the order of B and A in here doesn't matter either, because 2 times 3 is the same as 3 times 2. Multiplication is also commutative. And now we plug in what we know. B is 152. A is 152. Minus 2 times 152 times 152 times cos of 80. So this gives us 23,104 plus 23,104 minus 8,023.934 and so on. So that gives us c squared, which is 38,184 point something. We square root both sides of this equation, and that gives us a value of 195.4 meters. So we know how to find a missing side length. What about finding a missing angle? So in this question we need to figure out angle z. This is side length z, this is side length x, and this is side length y. So the variables in this triangle don't match up with the formula that we were given, but we can adapt this formula because the angle that we need to find would be here on its own, and the other two would be first and on the bottom. So we can adapt and call this cos of capital Z equals x squared plus y squared minus z squared divided by 2 times x times y. And now we just sub in what we know. So x is 12.3, y is 8.2, and z is 5.1. And then we divide by 2 times 12.3 times 8.2. So on the top we would have 151.29 plus 67.24 minus 26.01, and that's all over 201.72. So next we would add up all of these numbers on the top and then divide by 201.72, which would give us 0.95439 and some other digits. That is equal to cosine of z. If we want to figure out what z is, we take the inverse cosine of both sides, and we get z is 17.4 degrees. So that's it for me for today. You can do these questions, and I'll see you next time.